5 minutes at normal speed, while the decorative egg allows between an hour and 75 minutes of charging. Plurobot. The company BioRob, which works in the creation of new generation bionic robots, has presented a robotic lizard, whose behavior resembles that of a salamander. To faithfully reproduce the particularities of the movement of these lizards, the developers used X-ray images. This allowed them to accurately recreate all the details of the animal. Like true lizards, which have great mobility, their mechanical analogues can also move through difficult terrain and even swim. A waterproof skin allows the device to remain for a long time in the water, which is why this bionic animal can be used for search and rescue. The construction of the robot allows controlling each active joint separately, whereas a model of neural networks responds for the control of the robot. The structure simulates the nervous system of some parts of the brain of a real salamander. This approach allows the robot to accurately copy the studied movements, in addition to performing complicated tasks which go beyond the possibilities of a real salamander. According to the developers, they hope to continue with their creations, and probably in the near future will show us a robotic dinosaur. Airacuda. The company Festo, famous in the world for its robotic animals, has presented their new son, the robot fish Airacuda. In addition to fins motors, which allows copying the exact movement of a real fish, the device has liquid muscles, a creation patented by the company itself. These muscles have elastic hoses made of rubber as well as aramid fiber. Using compressed air, the mechanical muscles move in the same way normal muscle tissues move, stretching or contracting as needed. 2 muscles are enough to begin the movement of the rear flap of the fish robot, while 2 other muscles are responsible for the control, allowing great maneuverability even in deep waters. Like a real fish, inside this robot there is a swimming bladder, a special cavity that allows regulating the compressed air and setting the fish in motion. To use this mechanical fish for 30 minutes, you need 400 liters of compressed air. Aqua Jelly. Here we have an autonomous artificial jellyfish with an electric propulsion system and an intelligent mechanical system, which can adapt to any external changes. A transparent hemisphere and 8 tentacles with LED lights make up the bionic jellyfish. Inside we can find a central motor, 2 lithium-ion batteries, a navigation block and 2 servo motors to control the movement. The robot's able to calculate the power supply, and when the battery's running out of power, the device automatically sends the information to the charging base located on the surface and swims to it on its own. To communicate on the surface, the mechanical jellyfish uses a radio band, and when being underwater, it uses a system of infrared lights, with a working distance of about 3 feet. That way, when receiving the signal from another robot in the vicinity, the jellyfish can perform an evasive maneuver. In addition to the environment sensors, the robot has internal sensors to control the energy level and pressure, thus calculating the immersion depth with high accuracy. Eloom. This robotic snake, developed by the Norwegian Institute of Science and Technology, has been specially created to work underwater. Its mission is to perform observation and repairing works of oil facilities, as well as recording videos underwater and investigating sunken ships. A cable is currently used to interact with the robot, but in future it will be able to swim autonomously and perform underwater research without an external signal. The elastic electronic construction of the underwater device allows its use in complicated places, which cannot be reached other than using other special equipment. That way, the bionic snake is a cheap and practical solution to perform technical tasks of low difficulty. This robot can help perform inspections, illuminate dark areas, clean underwater constructions, and screw nuts and valves. RoboCrab. The creators of this unusual robot were inspired by the Ziphosaura, one of the oldest animal species on planet Earth. The device moves using a set of small legs, pushing itself away on the surface, and is able to return to its initial position using its movable tail, in case the robot turned on its belly. Like the animal prototype, this mechanical